Problems on addition and subtraction of matrices. So the first question, if the matrix A is equal to 1 2 minus 3 5 0 2 1 minus 1 1 and matrix B equal to 3 minus 1 2 4 2 5 2 0 3, matrix C is equal to 4 1 2 0 3 2 1 minus 2 3, then compute A plus B, B minus C, and also verify that A plus B minus C is equal to A plus B minus C. So we will discuss the solution for the example. So simple. First you need to check the order of A and B. So the order of A is 3 cross 3 and the order of B is also 3 cross 3. So to obtain A plus B, we go on adding the corresponding elements. So write down the two matrices. Okay, now add the corresponding elements. 1 plus 3 4, 2 minus 1 1, minus 3 plus 2 is minus 1, 5 plus 4 is 9, 0 plus 2 is 2, 2 plus 5 is 7, next 1 plus 2 is 3, minus 1 plus 0 is minus 1 and 1 plus 3 is 4. So this is how we get A plus B, just by adding the corresponding elements of the two. Next we will obtain B minus C. So write down the two matrices. So subtract the corresponding elements of the two matrices. We get 3 minus 4 as minus 1, minus 1 and minus 1, it gives minus 2, 2 minus 2 is equal to 0, next 4 minus 0 is 0, 4 minus 0 is 4, 2 minus 3 is minus 1, 5 minus 2 is 3, 2 minus 1 is 1, 0 minus of minus 2 it will be plus 2 and 3 minus 3 it will be equal to 0. So we have obtained the value for B minus C. Next we need to verify A plus B minus C. We will verify the given condition. So for that we will consider first A plus B and then subtract C from the matrix A plus B. So already we have obtained A plus B. We will consider A plus B. Next we will subtract the matrix C from A plus B. So again subtract the corresponding elements. We get 4 minus 4 0, 1 minus 1, next minus 1 minus 2, 9 minus 0, 2 minus 3, 7 minus 2, 3 minus 1, minus 1 minus of minus 2 it will be plus 2 and 4 minus 3 which is equal to 1. So this is the LHS part of the given equation. Next we will calculate the RHS part. A plus B minus C. So B minus C we have already calculated. So to B minus C we will add the matrix A. So the matrix A is 1 2 minus 3 5 0 2 1 minus 1 and 1 plus the matrix B minus C. So again add the corresponding elements. 1 plus minus 1, 2 plus minus 2, minus 3 plus 0, 5 plus 4, 0 plus minus 1, 2 plus 3, 1 plus 1, minus 1 plus 2 and 1 plus 0. So we get the matrix A plus B minus C, and then we can write A plus B minus C is equal to A plus B minus C. Okay, and hence it is verified. Next, we will consider another example. If matrix A equal to 2 by 3, 1, 5 by 3, 1 by 3, 2 by 3, 4 by 3, 7 by 3, 2, 2 by 3, and matrix B is equal to 2 by 5, 3 by 5, 1, 1 by 5, 2 by 5, 4 by 5, 7 by 5, 6 by 5, and 2 by 5. Compute 3A minus 5B. So see, here first we need to obtain the scalar multiplication of the matrix A, that is 3A, and then scalar multiplication of the matrix B, that is 5B, and then subtract the both matrices. So first we will obtain 3A. So multiply each element of the matrix A with 3. Next, similarly multiply the element of matrix B with 5. So multiplying every element of A by 3 and B by 5, we get 3 into 2 by 3, that is first element, 3 into 1, next 3 into 5 by 3, 3 into 1 by 3, 3 into 2 by 3, 3 into 4 by 3, 3 into 7 by 3, 3 into 2, and 3 into 2 by 3, minus multiply each element of B with 5. So we get the matrix in which every element of B is multiplied. On simplifying, we get, so cancel off and simplify. So on simplifying, we are getting the two matrices, that is 3A and 5B. So subtract the two matrices, we get 2 minus 2 as 0, 3 minus 3 is 0, 5 minus 5 is 0, 1 minus 1. So you can see all the elements of the first matrix are equal to the elements of the second matrix, and on subtracting we are getting a 3 cross 3 0 matrix. Matrix multiplication. The concept of matrix multiplication is important from board exam point of view as well as competitive. It will help you to fetch many marks in the board as well as competitive exams. So very important concept. So multiplication of matrices. So we are considering two matrices A and B of order m cross n and p cross q respectively. So two matrices can be multiplied only if the number of columns of the first matrix is equal to the number of rows of the second matrix. So here we are using a rule called CR rule, that is column of the first must be equal to the rows of the second matrix. So in the above example, the number of columns of matrix A is n and the number of rows of the matrix B is p. So the first condition for multiplication is n must be equal to p. N must be equal to p. So once we check n is equal to p, we can continue with the process of multiplication, and the order of the resultant matrix will be m cross q, will be m cross q. So here in the multiplication we need to understand the first condition for multiplication is n must be equal to p, and the matrix obtained on multiplying A and B will be of the order of m cross q. m cross q. So we multiply the two matrices using row column method. That is, always multiply the row elements of the first matrix to the corresponding column element of the second matrix. So we will consider an example to understand the row column method. So first example, matrix A equal to AB minus BA of order 2 cross 2 and matrix B equal to A minus B BA of order 2 cross 2. So here you can see that the columns of the first matrix and rows of the second matrix are equal, so multiplication is possible. And the order of the new matrix will be 2 cross 2. So we'll start with the multiplication process. So first we are multiplying the row of matrix A with the first column of matrix B. So A into A we get A square plus second element into second element we get B into B. Next we will multiply the first row with the elements of second column. So A into minus B plus B into A. Similarly, we will multiply the elements of the second row with the first column. So minus B into A plus A into B. Next, we will multiply the elements of the second row with the second column. So we get minus B into minus B plus A into A. On simplifying it further, we get A square plus B square as the first element, minus AB plus BA, next minus BA plus AB and B square plus A square. On further simplifying the second and third element, we can simplify it. So we get A square plus B square 0, 0 B square plus A square. So this is the required matrix and the order of this matrix is 2 cross 2. Consider another example, matrix A equal to 1 2 3. Order of the matrix A is 3 cross 1 and matrix B equal to 2 3 4. The order of the matrix B is 1 cross 3. So again we need to check the CR rule, that is, column of the first matrix must be equal to the rows of the second matrix. So number of columns of A is equal to number of rows of B in the given matrix, and the new matrix will be of the order of 3 cross 3. So A into B is equal to, so multiply the first row with the first column, that is 1 into 2. Next the first row with the second column, we get 1 into 3. Next first row with the third column, we get 1 into 4. Next similarly multiply the elements of second row with the first column of B, second column and third column. We get 2 into 2, 2 into 3 and 2 into 4. Lastly, we need to multiply the element of third row with all the 3 columns of B. So we get 3 into 2, 3 into 3 and 3 into 4. On simplifying, we get 2, 3, 4, 4, 6, 8, 6, 9 and 12 as the product of A into B, and the order of A into B is 3 cross 3. Properties of matrix multiplication. So the first property, for any three matrices A, B and C, A into B into C is equal to A into B into C, and this is called as the associative law for multiplication of matrices. So this is possible whenever both the sides of equality are defined. So here the word defined means the matrices satisfy the CR rule. Second property, for any three matrices A, B and C, A into B plus C is equal to A into B plus A into C. Second, A plus B into C is equal to A into C plus B into C whenever both the sides of the equality are defined. So this is known as the distributive law for multiplication of matrices. Property number 3. For every square matrix A, there exists an identity matrix of the same order such that I into A is equal to A into I, which is equal to A. So here I is known as the multiplicative identity. Next, property number 4. Commutative property does not satisfy for matrix multiplication, that is A into B is not equal to B into A. Next we will discuss some more example based on multiplication of matrices. Compute A into B and B into A, where A is equal to 2 4 minus 1 0 5 1. So the order of A is 3 cross 2 and matrix B equal to 2 minus 1 4 5 1 0. Order of matrix B is 2 cross 3. So before obtaining the product A into B, we need to check the columns of matrix A must be equal to rows of matrix B. So 2 is equal to 2. So it satisfies the CR rule. And the product of A into B will be of the order of 3 cross 3. So again we will start the multiplication procedure by multiplying the elements of first row with the first column of B. So 2 into 2, first element into first element, plus second element into second element. We get 4 plus 4 into 5, it is 20. So 4 plus 20 will be the first element. Next, second element, we are multiplying the first row with the elements of second column. So 2 into minus 1, we get minus 2, and 4 into 1, we get plus 4. So minus 2 plus 4. Third element is obtained by multiplying the first row with the third column. So 2 into 4, we get 8, and 4 into 0 is 0. Next, we are multiplying the elements of row 2 with the first column, second column and third column to obtain the next three elements. So minus 1 into 2 plus 0 into 5. We get minus 2 plus 0. Next, minus 1 into minus 1 is plus 1 and 0 into 1 is 0. Next, minus 1 into 4 is minus 4 and 0 into 0 is again 0. So we get minus 4. Next, we multiply the elements of R3 with the first column of B, second column and third column. So 5 into 2 is equal to 10 and 1 into 5 is 5. Next, 5 into minus 1 is minus 5 and 1 into 1 is 1. 5 into 4 is 20 and 1 into 0 is 0. So we simplify it further. A into B is equal to 4 plus 20 is 24. Next, 2, 8 minus 2 1 minus 4, 15 minus 4 and 20. So we have obtained A into B. Next we will obtain B into A. So for B into A, write down the two matrices B and A. So first we need to check the orders, that is the columns of B must be equal to rows of A. So you can see 3 is equal to 3. So multiplication process is possible, and the order of the new matrix will be 2 cross 2. So B into A is equal to, so multiply the elements of first row with the elements of first column of matrix A. So 2 into 2 we get 4, minus 1 into minus 1 is plus 1, and 4 into 5 it is 20. Next 2 into 4 is 8, minus 1 into 0 is 0, and 4 into 1 is 4. To obtain the next two elements, multiply the elements of R2 with C1 and R2 with C2. So 5 into 2 we get 10, 1 into minus 1 is minus 1, and 0 into 5 is 0. Next 5 into 4 we get 20, 1 into 0 is 0, and 0 into 1 is again 0. So simplify it further. B into A will be equal to 25, next 12, 10 and 20. Consider another example. Compute A into B for the matrices A equal to 2, 3, 4, 3, 4, 5, 4, 5, 6 of order 3 cross 3, and matrix B equal to 1 minus 3, 5, 0, 2, 4, 3, 0, 5. So you can see the order of both the matrices A and B are same. The number of columns of A is equal to number of rows of B, and the resultant of both the matrices will have the order 3 cross 3. So elements of first row into first column, we get 2 into 1 is 2, 3 into 0 is 0, and 4 into 3 is 12. So write down the sum of the products of these elements. Next 2 into minus 3 is minus 6, 3 into 2 is 6, and 4 into 0 is 0. Multiply the elements of R1 with C3, we get 10, 12 and 20. Similarly, continue the procedure. Multiply the elements of R2 with C1, then R2 with C2, R2 with C3. We get 3, 0, 15, minus 9, 8, 0, and 15, 16, 25. Next, multiply the elements of R3 with C1, C2 and C3. So we get 4, 0, 18. Next, minus 12, 10 and 0, 20, 20 and 30. So add all the elements. First element will be equal to 14, second 0, third 42, next 18 minus 1, 56, 22 minus 12 and 70. So the order of A into B is 3 cross 3. Simplify. Next question. Simplify cos theta into cos theta sin theta minus sin theta cos theta plus sin theta into sin theta minus cos theta sin theta. So here First we need to apply the property of scalar multiplication. Multiply the first matrix, each element of the first matrix with cos theta, and multiply each element of the second matrix with sin theta. So on applying the property of scalar multiplication, we get cos theta into cos theta is cos square theta. Second element will be cos theta into sin theta, which is sin theta cos theta. Third element cos theta into minus sin theta is minus sin theta cos theta, and cos theta into cos theta is cos square theta, plus multiply the second matrix with sin theta. Sin theta into sin theta we get sin square theta. Next minus sin theta cos theta. Third element sin theta cos theta, and sin theta into sin theta is sin square theta. So now consider the addition. Apply the addition property of multiplication. So we need to add the corresponding elements. So first element plus first element, that is cos square theta plus sin square theta. Next second element plus second element, sin theta cos theta minus sin theta cos theta. Third element, add the third elements, minus sin theta cos theta plus sin theta cos theta. And then the fourth elements, cos square theta plus sin square theta. So we already know the identity, basic trigonometric identity, cos square theta plus sin square theta is equal to 1. So in the place of first and fourth element we can substitute 1, and the second and third element we can simplify, and the sum is equal to 0. So we get 1 0 0 1, which is an identity matrix of order